Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is letting the compiler deduce template parameters. Before proceeding, make sure that you have already watched these other videos first. It used to be that you always needed to list the types for template parameters when the template was being specialized. For example, listing the int and float types in this specialization of the pair template. This annoyed some programmers. At least in the case of pair, there was a shortcut. Programmers could call the makePair function, which is an overloaded function that merely returns a pair for the compiler temporary. By passing an int and a float to makePair, you're selecting its overload, which returns a pair where the template parameters are int and float. That saves the programmer from having to type those two type names again, which some programmers like better. But you don't need to do that makePair anymore, because starting in C++17, the type name of this compiler temporary, which is pair int float, can automatically deduce the type names for the template parameters. The compiler figures them out itself from the context, although we prefer not to use this shortcut because we consider it to be less clear. The template parameters can also be deduced where the programmer is specifying the type of a variable. Here's a detail to watch out for. Remember from our video about uniform initialization that this form, using braces, will uniform initialize a vector to having one element whose value is 3, while this other form, using parentheses, causes a constructor to initialize the vector to have 3 elements. Now, consider what happens when we let the compiler deduce the int template parameter. For the form that used braces, everything works just fine. The compiler successfully deduces that the template parameter should be int, and it uniform initializes the same as before. But the form that used parentheses now becomes the compiler error. The compiler knows that you want to initialize a vector to have 3 elements, but the compiler has no way of guessing what type those elements should be. Because of concerns over exception safety, you still need to manually list your types for template parameters when you are using smart pointers. You also still need to manually list your types for template parameters if you have a pointer or a reference.